Welcome, everyone. Oh, that was louder than I expected. Welcome, everyone. Thanks for coming to the talk here. So bite-sized talk, so 15 minutes, and the topic is Scream if you want to go faster. Apologies, we did have to change the talk topic at the last minute, so if you're expecting a different talk, my apologies. But I'm going to talk about security instrumentation and how it enables development teams to go faster. So maybe some of you have read the Phoenix project. This is the 3 ways of DevOps extracted from the Phoenix project. So the 3 sort of core concepts here are flow, feedback, and culture. And basically, flow is about making work visible. We do that within our tools like Jira for ticketing and so on. We limit work in progress to make sure that we're completing items before we move on to the next item and so on. Reducing batch sizes, we do that in sprints, to make sure we have a deliverable at the end of 2 weeks. And we want to reduce handoffs, like any friction to operations teams, QA teams, or security teams as we promote builds into production. We then get into sort of feedbacks. It's kind of like the next level of DevOps, which is where we're swarming problems, failing fast, finding out if we have issues within our product early on within the SDLC. Most people are familiar with this concept of shifting left. It started in the quality world. I think 2001 was the first reference to shifting left. Idea is fixing problems earlier in the SDLC is beneficial. But I'm going to challenge that a little bit when it comes to security, because not all context is available if you shift very far left with security. We also want to optimize for downstream and perform reviews and retros, etc. And then finally, you get into like culture. So if you have your flow and feedback in place, you can start to get into culture, safety culture, chaos engineering, things that really enable us to all improve as a group. But what happens if we start to lay security into these 3 ways of DevOps? So firstly, we end up with lots of false positives. Lots of scanning tools produce large amounts of results. They need triage process. So that kind of work ideally would go into our ticketing system so that we could track that work. But ultimately, we have to go through a triage process because the results that you get from a lot of the different tools in this space don't enable you to push all those results into Jira. You would very much upset development teams and product owners. Second thing we want to do is limiting work in progress, and security gets in the way here because if you are in the middle of a feature and then suddenly you find out about a vulnerability from a scan maybe the night before, or the security team did a DAS scan, you have to revisit that original feature. So you're changing context and you're not really limiting work in progress. We also affect handoffs. So if you've got security results that need review, maybe from the security engineering team or an expert in vulnerability triage, you very much have to loop those people in, and it's another bottleneck in the process. And then finally, we want to eliminate waste in DevOps, but configuring scans is basically manual work. Triage is manual work. These are all things that are unplanned, that affect the output of development teams. And developers aren't the experts in configuring these types of security tools, or indeed doing vulnerability triage. As we get into failing fast and getting fast feedback for developers, well, these scans break the magical kind of 15-minute feedback loop. I'm sure many of you are running like unit tests and things like that within a pipeline. And if your scans are taking longer than 15 minutes, you sort of have to take those out and run them in a separate pipeline or maybe a parallel security pipeline, all of it delaying the feedback that the developers get for the code they just wrote. And then if we have moved some security tools left, is it efficient? Is it the best place to run security tools when the context is not available? Not all vulnerabilities are visible by looking at code in a repo. They involve looking at the configuration of application, environment variables, are the connections secured between different services, and so on. Not all that is visible within a repo. And lastly, are we performing continuous improvement or just doing continuous triage? Because we end up getting these results and we go through the same process over and over again of trying to filter out the noise from the true positives that we have. So if we look at what the world has told us that you need from a modern security pipeline, we push our custom code and libraries in the left-hand side. And some of us do SAST at the IDE. This is like the most lightweight possible version of SAST that's available. It's not capable of doing deep, complex data flow analysis that you get with tools that you typically deploy in a pipeline. So you might get some early results. You might also get some false positives straight away to deal with. We're starting to add to the security backlog by revealing issues from within the IDE. We then push code into a repo where you're probably doing some kind of SCA and SAST analysis. And at this point, you're all getting a lot more false positives, particularly around the SAST side. And then finally, that build ends up going through a DAST tool late in the SDLC. Again, a few more false positives to deal with. You might do a pen test before you release into production. Don't normally have many false positives with pen tests, but it's another source of vulnerabilities that needs to be dealt with by developers. And then if you have this amount of security backlog, the security team are probably going to end up and insist that you put a WAF in place. And then you have the kind of problem with tuning and tailoring a WAF to deal with modern applications. All of this ends up building up a security backlog, which in my experience tends to get like risk accepted or developers try and avoid these processes. And the outcome of that is that we reduce the flow. We don't put as much code into production and we reduce business value. So how can we restore DevOps speed? Well, firstly is improve the accuracy of the tooling. If we can just get fewer numbers of results, but highly accurate results to developers, we should improve DevOps speed. Secondly is restoring the fast feedback loop. We want developers to get their results, as soon as they're available. But we want to make sure that those results come quickly. We don't want to be waiting hours or days for a scan to finish. You want to get those results within a few seconds, ideally, a few minutes, worst case. And lastly, we want to make sure that development and security teams can visualize, understand, and mitigate the risks. These issues, if they're very accurate, we can put them in our backlog, we can deal with them in our sprint planning, and we can remediate them within that sprint or the following sprint. We can get on top of that quite quickly. And the goal here is actually to reduce MTTR. There is no point discovering vulnerabilities in applications unless you're going to actually fix them. There's plenty of tools out there that bring you lots more problems, but ultimately, you're not improving your risk posture until you get those remediated. So we must focus on MTTR. So how can we do things a bit differently? On the left is the smartwatch I wear on my wrist. Tells me all sorts of information. It's instrumented my body in a way. It tells me pulse, heart rate, sleep, all those types of things. There's 10 sensors on that. In the middle is an F1 car, right? F1 car has about 500 sensors. I would say roughly half of those are for performance, but also they're for security. They're measuring the temperatures of things. They're measuring the G-forces. They're measuring all sorts of things about the car. And then as we get to the right-hand side, the airline industry, as you know, has an amazing safety record. An Airbus A380 has about 3,000 sensors, again, looking for performance and security as well, safety. And if we think about software, we all use APM tools to measure the performance of the software. But if I asked the audience how many people would be using sensors to measure the security of the software, probably no one. Maybe one or two people have tried it out. So this I want to talk about is modern security for modern teams. So Contrast is one of the vendors that provide IaaS security. So this is instrumented application security testing. And the way this works is that we inject sensors inside of the entire application. So this includes the custom code, the libraries, the application server. You can see the full stack. What this does is it enables real-time testing of the application in pre-production environments. So as your application is serving normal traffic, it's analyzing those requests, making sure that there are no vulnerable code flows within those applications, and also monitoring if you have any vulnerable libraries and whether you're using those libraries at runtime. What this enables is that as developers are working on a feature or as they run their CI/CD tests, we're constantly feeding back all of the vulnerability telemetry back to the developers to let them know if they just introduced a vulnerability within their application. As that application goes into production, we can then use those same sensors to prevent applications from being exploited. So use cases typically in production would be, maybe you've got some applications, you've got some vulnerabilities that you didn't have time to fix. You might have some legacy applications that you don't have active development on. You might have some third-party applications in your environment. Those same sensors can be used at runtime to be able to prevent applications from being exploited. So sensors provide real accuracy. I've spoken a little bit about SAST. SAST can only look at code and model how a code executes. So it's a very limited window of view that SAST has. DAST or WAF technology works by looking at just a HTTP request and determining whether a vulnerability exists by HTTP requests is a very challenging and difficult problem to solve. IaaS and Contrast can actually see the full application stack. So we can see problems in the code like weak encryption, insecure algorithms. We can see problems in the configuration like maybe the database is misconfigured. And more importantly, we get to see the runtime data flow and control flow. So that means that every single string that comes into your application, we can accurately track in memory through the process to see if you use that string in an unsafe way. So let me just explain how that works. So the code analysis happens immediately at startup, and then the runtime analysis takes over. So the code analysis picks up the simple stuff, the configuration issues, the insecure hashes, anything that doesn't change once the application started is detected at startup. Then runtime analysis takes over. So when a web request arrives at the application, we look at the header values, the URL parameters, the cookie values, the request body. You might be receiving a JSON object, for example. We will track every single string that come in through the front door, all the way through the application and the libraries until it reaches a vulnerable part of your application. And that could be something like a SQL query, a file system operation, a network request, even HTTP response. All of those are vulnerable parts of the application. And by monitoring that in real time, the accuracy is huge. You're looking at 95% plus accuracy of the application. But we also monitor how much of the app you've tested. So you get feedback at all times about whether you've tested all parts of the application at runtime. And if you can deliver smaller sets of results to developers, they can remediate them faster and ultimately reduce risk. So that's really what the product is about. We support all the languages at the bottom there, so basically web languages and APIs. And what it enables developers to do is to move much faster as they progress code to development, because they're not being held up by waiting for security scans or DAS scans or anything that happens in the general security work that people do. They can do their security in real time, fix vulnerabilities in real time, push their application to production, and if they wish to, they can apply runtime protection in production to prevent exploit there as well. So accuracy-wise, it is measurable. There's a project called the OWASP benchmark. There's around 3,000 test cases. This type of project is actually used to assess the accuracy of security tools. So you'll see there are various different tools in here, like OWASP Zap. You tend to see the cluster of DAS tools down on the left-hand side, and you see a spread of SAS tools all up on the right-hand side. But what all these tools have in common is a very high false positive rate. Contrast and generally IaaS products, we're not the only IaaS product in the market, but IaaS in general scores 100% on this benchmark, meaning that it found every true positive and 0 false positive. So that's really helpful. I think it enables you to move faster as a team. But what's the catch? So first thing is, like an APM, the agent does require some changes to the application's configuration or runtime. So for Java, we need you to add a little JVM parameter that specifies you want to use a Java agent. For .NET, it's a profiler, and so on. Most vulnerability types, especially data flow vulnerabilities, do require traffic to be detected. So you will have to have some test suites in place. I'm not talking about unit tests, just integration tests or end-to-end tests, anything that tests your application. And you can test it in multiple environments as well. And in return for sort of doing those two things, you'll get real-time feedback, low false positives and low false negatives. We'll discover all of the routes and APIs within your application, identify if your application is actually using vulnerable libraries. So not just did you include Log4j, but which parts of Log4j have you used within your code base. You'll get feedback on your end-to-end test coverage, and hopefully less time to, do setup, triage, more time to build fun stuff. So that's really what this is about. 2 minutes left for a quick demo here, so I'm just going to go very quickly into our UI. I do have a project here. It's a Java project, and what I'm just going to do is, firstly, I'm just going to clear down all the vulnerabilities that exist within this project. So if I come to the Vulnerabilities tab and just remove everything. Oops, don't know, something on the Mac got in the way there. There we go. So I'm going to remove the vulnerabilities, and then I'm going to launch this project from my IDE. So you'll notice when this project starts logging out that you'll see some stuff from Contrast. So it's compiling the application now, and then it's launching the application. Contrast just started logging in the console here to say it's running in assess mode, so it's looking to detect vulnerabilities. And this is just starting the JVM. We typically add about 3 seconds, so we will add just a small amount of startup time in pre-production. And then this will eventually just carry on and load up this application, which is a web app. Give it a few seconds. I think we're ready. Okay, great. So it's running in my browser. And at this point, like a developer, like this is a sort of web app, but if API is exactly the same. You would go and test the particular endpoint or test the API. So let's just put DevOps in here so you can see what this ends up looking like. Hit restore, tells me the user DevOps does not exist. In the meantime, if I come back into contrast, I will have a fresh set of vulnerabilities from the test cycle that I've just done here. So just my network request runs quick enough. Time's up. Come on, I lost Wi-Fi. Or our SaaS platform just went down right in the middle of my talk, but hopefully that's not the case. Okay, eventually we got there. Okay, great, so this is what I was expecting to see. So these are all the vulnerabilities that were detected. So this is a blend of different types of vulnerabilities, but most importantly, we have a critical. So what does that look like? Here's my web request, here's where it went to in the source code, and here's the database query that was run. Hopefully very clear for a developer to understand. We explain the risk, they can see the data flow, everything that needs to go with it. So yeah, that was my subject. Help developers go faster by screaming, really screaming at the security teams to say, can we just try something different? And that's the subject of the talk. So thanks for coming. Any questions?
Would you have a stand downstairs and got pick and mix? Some class and also give the other one a demo.
Maybe a quick one. What's the amount of the traffic between the server and your SaaS service?
So actually, we do provide it on premise. If you'd rather just run things in-house, that's perfectly fine. We have measured the agent traffic. It's roughly a megabyte per hour while the application's being tested. Obviously, if the app's not running, then there's no traffic. But it's only active when the app's running. Yeah.
It's only reporting once per found vulnerability, or?
Correct. Yeah. So it will deduplicate based upon the root and various aspects.
Reported already once. We don't need to do.
Correct. Yeah.
Okay.
Yeah. It will just update. There's a last updated here, you'll see. So if we detect it again, we'll just update that flag, but it won't report a duplicate.
Yeah, because I'm thinking about what happens in production when I have 150,000 requests per second.
Yeah.
To all the endpoints, and we do have so many requests. So.
Yeah. So typically it gets used in pre-production, most scenarios. Yeah. Yeah. You can use sampling if you are dealing with large amounts of traffic. You can just sample every 10th request. Yeah.
Because when we are doing testing, it's not only we are doing testing, it's all different
Partners, customers, anything. Yeah.
Yeah, premium customers are doing testings and so on. Can you also filter out the requests to, for example, different customers? For example, only one part of your customer groups uses a specific API, so they could be vulnerable, or?
Definitely, you can filter based on the URLs. You can filter based on applications. So if you're running a number of applications on IIS, for example, you can filter just to target certain applications. But what your sounds like, if you target by URL, that would exclude certain parts of your application from filtering.
Okay.
Yeah.
Thank you.
No worries.